Hello everyone, I am Dr. Mohit and today I am going to explain a very important theorem in mathematics, that is Intermediate Value Theorem. To understand the theorem, let's look at two simple real life situations. First is, here we have a hiker climbing a hill. After 1 hour of starting, at t equal to 1 hour, the hiker reaches at height of 300 meters. After 3 hours, at t equal to 3, hiker reaches at height 900 meter. Now the question is, will the hiker reach intermediate height of 600 meter at some moment during the climb from 300 meter to 900 meter? Or is there any value of t at which hiker reaches at height 600 meter? So answer is yes. Why? Because the hiker is climbing smoothly. He does not suddenly jump from 300 meter to 900 meter. To reach at a height of 900 meter, definitely he will pass through every height in between. Means he will reach at 400 meter at some moment, at some value of t. He will reach at 500 meter. He will reach at 600 meter, 700 meter, and so on at some moment t. Now, now look at the car example. At t equal to 0 seconds, car speed is 0 kilometer per hour. After 10 seconds, the speed becomes 40 kilometer per hour. So question is, will the car have an intermediate speed of 20 kilometer per hour at some moment during its smooth acceleration from 0 kilometer per hour to 40 kilometer per hour? Or in other words, we can say, is there any value of t? Is there any value of t at which car speed will be 20 kilometer per hour? So again answer is yes, because car speeds up smoothly. It cannot jump from 0 kilometer per hour to 40 kilometer per hour directly. Definitely car will pass through 10, 20, 30, and all the speeds in between at some moment t. So, what mathematical property guarantees the existence of all these intermediate values? Okay, at some moment t. So, answer is continuity. So, continuity is the mathematical property that guarantees the existence of all intermediate values in both situations. So continuity means the value changes smoothly with no jumps and no sudden breaks. Hence we can say continuity guarantees the existence of all intermediate values. Let's understand the intermediate value. The key idea behind the theorem, intermediate value theorem, that is also called IVT. The key idea is that a continuous function cannot skip values. Theorem says that if a function fx is continuous on the closed interval ab, then for any value y0 between f of a and f of b, there exists at least one value c that belongs to open interval ab, such that function value at c is y0. So in simple words, we can say if a function is continuous, it cannot jump any value. Definitely, it will take every value between f of a and f of b. Look at this graph. At x equal to a, function value is f of a. At x equal to b, function value is f of b. Choosing any value y0 between f of a and f of b, you can see here, because the graph of the function is continuous, definitely this graph must pass through the horizontal line y equal to y naught at some point. That is, at x equal to c, the function value is y naught, means f of c equal to y naught. Now look at the second graph. Here the function graph goes up and down. Okay, so in this graph, the intermediate value y naught is corresponding to three values: c1, c2, and c3. So here also fc1 equal to y naught, fc2 equal to y naught, also fc3 equal to y naught. So these two graphs show two important things. One is the function can have more than one values of x where it is equal to y naught. Second important thing is that the intermediate value theorem does not tell us about how many such x values x equal to c exist. It only guarantees that at least one value of x satisfies f of c equal to y naught. Now, how to use intermediate value theorem to show that an equation has a solution. So in this example, we want to prove that the given equation has a solution in the interval 0 to. Let function is 2x raised to the power 4 minus 3x square. So our goal is that to show that fx equal to 3 has a solution in interval 0 to. That is, function value is 3 for some values of x between 0 and 2. First we check the continuity. So given function is a polynomial and every polynomial is continuous everywhere. So function is continuous on the interval 0 to also. It means we can apply the intermediate value theorem. Now we find the values of function at endpoints. At x, at a equal to 0, function value is 0. At b equal to 2, function value f of 2, it is 20. Since the function is continuous and intermediate value y not equal to 3 lies between f of 0 and f of 2, means 3 lies between 0 and 20. So by intermediate value theorem, we can say there exists some c belongs to this open interval 0 to such that f of c equal to 3. That is 2c raised to the power 4 minus 3c square equal to 3. Hence, we conclude the equation fx equal to 3 has a solution in closed interval 0 to 2. Now let's look at another example. In this example, using IVT, we want to prove that the equation, this equation is solvable. Means there exists some values of x satisfying this equation. So we start with the given equation, cross multiplying both sides, we get this equation, which is simplified to x cube minus x square plus 4x equal to 8. Now let function is this one, which is a polynomial of degree 3. Now we want to prove that f of x equal to 8, this equation has a solution. So means we show there are some values of x for which function value is 8. So first we check continuity of the function. So here function is a polynomial of degree 3 and all polynomials are continuous everywhere in R. So we can apply the intermediate value theorem. In this example, see, we want to find the solution of the equation f of x equal to 8, but interval is not given here. Okay, in previous example, interval was given 0 to 2, closed interval. But in this example, interval is not given. So we use trial and error method here to check the function values at some simple points. So trial and error method means trying few easy input values x until we find where the function values crosses the target value. And in this example, target value is 8. So we start with x equal to 0. At x equal to 0 is function value is 0. At x equal to 1 function value is 4. At x equal to 2 function value is 12. So the value 8, target value 8 lies between f of 1 and f of 2. Since the function is continuous, and intermediate value 8 lies between f of 1 and f of 2, so by intermediate value theorem, we can say there exists some c belongs to this open interval 1, 2, okay, such that f of c equal to 8 means c cube minus c square plus 4c equal to 8. Okay, so there are some values of x here which we denote c satisfying this equation. Hence, we can say that the equation fx equal to 8 has a solution in the interval 1, 2. Okay, means the given equation fx equal to 8 is solvable, means has a solution. So if you found this video helpful, please like the video, subscribe to my channel, comment and share. Thanks for watching. See you in the next one. Thank you.